Up slow.
Up slow.
Right to step over?
Yep. Very good. Shoot over here too.
Still are those three?
Maybe we should keep this stuff out.
Yes, we should.
Hi, I'm Ben Thoma, the mechanical lead here for the assembly, test, and launch operations of Curiosity, the next Mars rover. So just recently we installed the robotic arm. That was a major milestone for the project, not only for the engineers that worked on this arm for years, designing, assembling it, and finally delivering it, but for the project as a whole. Having the arm on the rover is a huge accomplishment. Now we'll be able to begin the testing of that arm while it's on Curiosity. It's a very complicated, very tricky maneuver to actually put the arm on the rover. We use a crane from above because this arm is so heavy. We need to delicately bring it over and actually secure it to the front of the rover. We're going to go through a series of electrical and functional tests where the arm will actually be exercised. It'll move around. We'll start to learn how to use the arm with Curiosity. The arm is really one of the fundamental parts of our ability to gather the science. At the end of the arm, there's several different instruments. There's a camera, there's a spectrometer, and there's a drill that will deliver samples up to the other instruments on the rover. So without the arm, we wouldn't be able to do a good portion of the science that we're actually going to Mars for. There's still a lot of activities that we have ahead of us, a lot of testing. While we're working on the rover down here in this facility, we have the cruise stage, which is the device that actually takes the entire spacecraft to Mars. That's currently going through a thermal vacuum test up in our 25-foot space simulator. This is a big morale boost. Over the last couple of months, we've finally seen some of the major pieces of hardware get put on this rover. Going back for the last couple of years, we focused a lot of our attention on the inside of the rover. All the electronics, the telecommunications, the thermal control system. Just in the last couple of months, as you've seen, we've installed the mobility system, the remote sensing mast, which sits up on top of the rover with its cameras, and now finally the arm. The rover finally is starting to look like it does in all these beautiful animations we've seen. So the team is very excited at these major accomplishments and our ability to move forward with testing. I'm Ben Thoma, and this has been your Building Curiosity Update.
My name is Sean Haggart. I'm a mobility engineer on the Mars Science Laboratory. So as you can see down there, we just recently completed testing the wheels and suspension system on the flight rover. Now, the mobility system might look familiar. It's a classic rocker bogie suspension system that we've used for the last 2 generations of Mars rovers. And it does a lot of things that actually the mobility system hasn't done in the past. So for this mission, the mobility system not only drives the rover around, it's also the landing gear. The wheels are actually the first thing that make contact with the surface of Mars. Now, just about everything you see on the mobility system looks black. But that doesn't mean it's all the same material. The tubes, the suspension arms coming down to the wheels, those are all titanium. The tires themselves, those are aluminum. The shell on those tires is actually a piece of machined aluminum that's about 30 thousandths of an inch thick. That's about the thickness of 7 pieces of paper. And when they're that thin, it makes them actually soft. And so they can behave in much the way that a rubber tire would behave and give you that springy load for landing, for driving over rocks. This test was sort of an obstacle course for the rover, because we have to drive over obstacles of certain heights. Those correspond to rocks of certain heights that we expect to see on the surface of Mars. And so those ramps were mimicking those rocks to make sure that we can actually drive over them and get to the science. Now you notice that it's 6-wheel drive and all 4 corner wheels steer. Now those wheels can steer plus or minus 90 degrees. And what that allows you to do is actually position the wheels, kind of toe in, and turn the rover in place. And that makes it a very maneuverable platform to position itself for science. Now what you saw in that test was actually top speed of the rover, about 4 centimeters per second. Or to put it another way, it takes about 40 minutes to go the length of a football field. We want to go slow, because when you're 50 million miles away from the nearest service station, it's okay to go a little slow and be a little careful. My name is Sean Haggart. This has been your Building Curiosity Update.
Hi, I'm Ben Toma, the mechanical lead for the assembly, test, and launch operations of the Mars Science Laboratory project. We've already sent the heat shield, the back shell, and the cruise stage. And on this trip, we're sending the descent stage and, of course, the Curiosity rover herself. There's an enormous amount of logistics involved in planning such an operation. When you're talking about moving an entire spacecraft, along with all of its support equipment, literally across the country, it takes months and months of planning and weeks to execute. Curiosity is flipped upside down for its ride to Kennedy Space Center, in the same orientation that it'll be for launch. In this orientation, we carefully wrap Curiosity in a big, huge bag. That bag acts not only as a Faraday cage, but it keeps Curiosity clean for her journey to Florida. When she's all bagged up and ready, we have many engineers and many technicians gathered around and safely lift Curiosity up and down into her shipping container base. We'll lift a big lid on top of that shipping container. It's that shipping container that is then used to transport her across the roads and across the air on her journey to Florida. We actually arrive at Kennedy on a C-17, a military cargo plane, which will land at the same landing strip that the shuttle lands at. The team and I are really looking forward to our launch this November from Kennedy Space Center. I'm Ben Toma, and this has been your Building Curiosity Update.
My name is David Gruhl, and I'm the Assembly, Test, and Launch Operation Manager for the Mars Science Laboratory project. I'm coming to you from a clean room at the Kennedy Space Center, where my team is currently conducting the final functional test of the MSL flight hardware destined for Mars. Over here, we have our crew stage. The crew stage is comprised of a solar array, several guidance sensors, and a propellant system that basically gets the MSL spacecraft from Earth to Mars. Once we get to Mars, the vehicle will have served its purpose and we jettison it and it burns up in the atmosphere before we actually make first contact with the atmosphere itself. The back shell is the vehicle over here in white, which provides an interface to a large deceleration parachute. And over here is the heat shield, and the heat shield has the protective insulative tiles that keep Curiosity safe as all the heat is generated as we actually wake our way through the Martian atmosphere. Behind me is the descent stage. The descent stage is the jetpack that safely gets Curiosity down to the surface of Mars. Unlike Pathfinder and the twin rovers Spirit and Opportunity, which utilized airbags to make it down to the surface, Curiosity relies on the descent stage and its jetpack to actually make it down to the surface. Using retro rockets and a terminal descent radar system, this is what actually carries Curiosity safely down to the surface so that it can actually get its wheels onto the ground and perform its science. So here's the star of the show, the Curiosity rover. Here, Curiosity looks the same way that she'll look when she makes it to the surface of Mars and deploys all of her mechanisms. Sticking up off the top deck of the rover is a remote science mast, which contains all of our stereo imagery. You can also see the 6 wheels, which will actually propel Curiosity around the surface of Mars, as well as the robotic arm, which is sticking off the front of the vehicle, with the turret, which allows us to do science on rocks that are in the vicinity of the rover and return samples to science instruments that are contained on the body of the rover itself. All total, there's 9 science instruments which will return all sorts of exciting science from the surface of Mars. Up next for us, we're ready to start stacking the vehicle, and from there we're looking forward to a great mission as Curiosity launches and lands on the surface of Mars next year.